What's up, guys? Welcome back to another episode of DevTalks with your host Travian, where we talk about engineering and technology wise. In this video, we're diving into what happened at CES. So, Nvidia, Jensen, he's such a great CEO. Out of all of them, Nvidia has been amazing at what they've been able to do and accomplish so far. So, in this video, we're gonna dive into some of the new stuff that he said that Nvidia is coming out with, and I have some takes regarding some of them. And we're going to go through some of it. So without further ado, don't forget to like, comment, and subscribe and share. It helps very much. I really appreciate it all. And let's dive in and get into this.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading with the Blackwell family.
Okay, so right here, the RTX 4090, that's what I want to dive into. But something that I want to address real quick to the kind of the language that Jensen was just speaking to about neural networks and everything. If you think of anything neural, you're always thinking about it's in mind, like your mind, your whole neural network that goes in there. When I hear a lot of these CEOs and now people, he's actually the first one that I've heard bring this up and put it this way, with when it comes to processing and everything regarded to AI. Basically, what an AI system is supposed to be is it's supposed to be like a brain-like system. So if you want to create something and give it a brain-like system so that it can be able to think and generate different stuff and be trained off of it and learn, you have to think of the neural network on how the brain kind of works in a sense so that you can be able to grow in this thing so that it's able to learn and act in the way that you want it to do. Now, if it gets too much like a human brain, that can cause danger stuff because, not every human thinks the same. There's a lot of edge cases that they have to check off and go from there. So that's a big check. This next thing right here, I want to dive into the 4090 because I don't even think I got a 4090. I think in my computer I have like a 3080, something like that. And in my PC that I built, I have to double check the specs of everything. I remember putting that thing together years ago by myself. But let's dive into this because what he's about to announce was so amazing, especially when you look at the performance and things. So let's dive into this real quick and then continue on.
RTX 5070, 4090 performance.
This instantly got there. I watched this live, and when he showed us, it went from $1,600 to you can get an RTX 5070 for $549 for the same performance of a 4090. So now all these people went out there. This is why I said sometimes this is why I never buy new technology right out the jump. Never. Because it's always at its most expensive state at that form. The Apple Vision Pros, I'm not going to buy one immediately because I know right out the jump that's going to be its most expensive form. But when Apple has years and years of time to develop it more and make the materials cheaper, it's going to be more inexpensive and you're going to get the same thing for less. At some point, you're going to be able to get something with the same performance And there's different RTX 50 series. I believe that he goes through it, but it's a third of the price for what you're being able to get for a third of the price. Everybody who is a PC builder who wants to upgrade their PC. I know so many people who wanted to get a 4090 so bad and they just couldn't, but you can get the same performance for a third of a price now. That is called growth in technology. That's how you're supposed to spend your R&D. How can we make this cheaper? They got this Blackwell chip that's going into everything now. They're able to make these actual products cheaper, and then they have the way more expensive version still, but that we're getting different forms. But how can you improve this and make it cheaper for your consumers? That's the way you're supposed to think. More people are gonna go out and buy this. I bet you when this came out, so many people were in awe about how you're still able to get the performance of a 4090 with the 5070 for a third of the price. That is amazing. It is amazing, and I think they're gonna dive into more of it right here. So let's just continue on and not have me ramble on too long. But yeah,
at 549. Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090.
and look at this. So this is one he showed us. This is the 4090s comparable. Then you have a TI where they have these AI tops, which he just went over with that new chip, the new Blackwell 50 series. And he was going over all the AI stuff and the neural things and how we're going to be able to use these products with AI properly. The 5080 is at $1,000. All three of these are still cheaper than the 4090. All three of them. It doesn't get expensive until you get to the 5090. And look at the difference in this. It almost doubles the AI tops that are part of this. Almost. For $2,000, for double the price. So I feel like that's an amazing thing. If you're definitely working with AI more and stuff, I would invest into this. Just even the 5070, I don't need anything more crazier than that. I'm not developing any AI yet on my computer. And I say yet as an asterisk because I'm a very curious person that likes developing and creating new stuff. But this stuff was definitely the highlight for me. There's this and an engineering assistant, which I think we're gonna get to a little bit later on. But those were my top two things about what he talked about in his 2-hour keynote.
Starting, of course, we're producing at very large scale availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1,299, this 5070 laptop has a 4090 performance. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle of the Blackwell system. So we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so
I don't think we've gone over um the models that Nvidia has to the disposal. Like we always talk about the kind of the products that they have, like the playground thing for their robots and stuff. But normally when we talk about models, a lot of people think of Gemini's models. They think of OpenAI's models. Now, even more recently, even Amazon, they have their own models and things. And we know Apple is not working on anything like that. Meta, I believe, is working on something. Can't remember which one it is, but I know they're definitely working on a model. I'm trying to remember the name. I can't remember it at all. But yeah, Apple's the only like main FANG company I believe that is not working on any known model. It's a shame because I really thought we would have been able to see a significant Siri upgrade with using AI and whatnot, and it just didn't go the way that we thought they would have. They don't really put too much effort in development in that sense, which we could talk more about later. But NVIDIA, I would assume they probably have the best one based on how all these other fan companies are coming to them, especially to train specific models and whatnot, and all their products that innovation they've done in the last year. I would say they probably have the best one, even though they're just now showing us more of them. I would say they probably have the best
all of
model.
this is now available online. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could robots as well as large language model processing pipeline that's processor for the car.
I want to see. It doesn't look like this video has it, and I'll dive into this at the end. My favorite part, well, I like watching the video key talks for two particular reasons. One, I like watching her because this video is getting long. We're gonna try to skip through some of this to a sense, like to just the reveal portions. And one, I like watching his keynotes because you will learn something every time. I feel like every time you go through a NVIDIA keynote or event, they talk about stuff at a high level that you can be able to understand or learn or pick up on more things that are going on that you may not reveal. Everything else is very product based, but how much do they dive into like the technicalities of it. I know Apple does to an extent, but nobody, I feel like nobody really pays that much attention to it. Maybe I'm the only one that pays attention to these as much more than other people, like the significant details to try to pick up and learn them. But that's why you won't see me fully talk about all of these particular things that come up, like the lidar, the USS, and stuff like that, because I'm not an expert in that, and I'm more curious about what they're releasing and stuff like that. We can see this is the one of their platforms here based on Blackwell and things. Oh, this is for the vehicle. So they said that they were partnering with Hyundai, I believe it was, and I believe Hyundai is a Korean car company, which so it's a close neighbor for them. Correct me if I'm wrong in the comments, but this is basically how they're partnering with cars to make EVs better. He listed out a bunch of different companies like Mercedes and things along that line. We can just see real quick if he's going to explain it a little bit more.
Our next generation computer for the car is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard.
Orin was crazy when that first came out. So if this is 20 times better in a year, that's insane, the progression that they're making. But yeah, so he did a bunch of stuff about cars in the live stream. I encourage everybody to watch the live stream and just don't come and look at these cliff notes, because he goes into so much detail about some of this stuff and like the companies that they work with that are really important, and it kind of gives you an idea of like what companies to pay attention to in this next year, because who they're investing more into in the upcoming days or years and whatnot from that degree. But we do know something about these chips. Recently I covered Rivian, and when we did a Rivian cover, basically, we were told stuff about how they have troubles with the chips being so expensive, and they have all these little black boxes in the car to be able to do it, make it do all of this different kind of stuff. I wonder how, if I'm trying to remember if Rivian makes those chips in house. I think they don't, and that's one of their issues. But I wonder if Nvidia's ones would help them a lot better in this case if they partnered with them to upgrade their vehicles. That's Rivian's a company that we talk about a lot on this channel. Not a lot, a good amount though. And references from that reminds me I actually have to make a special video for the year being up. But yeah, so without further ado, let's just continue on to the next part. I think it's the robots.
For general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars, and the reason for that is we spent 100 plus years building roads.
And most of these robots that you see up here, we've covered on this channel before. Boston Dynamics, Agility Robots, and you've seen a lot of these robots in their testing since I think we've seen Figure before, and we've covered them. think OpenAI was working with Figure also, and they had a contract with them. I don't see Tesla up here for their bots, but I'm assuming because they don't work with Nvidia in that sense. But we've covered all of these robots, and these is just the future of it. Look how many different companies are developing these things. It's scary at the same time. It's crazy. It's something new that we can have to look at and whatnot. But yeah, yeah. Look how awesome that is. And then we have the last thing is this AI supercomputer. And this I don't like because he talked about assistants. He talked about AI assistants, and this video doesn't have it, but I want to dive into that too.
NVIDIA's latest AI supercomputer. And it's fondly called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA's software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And
this is a crazy thing. And the reason why this is crazy, because you look how small this is, but you also have to think Apple has something similar to these. This looks about the same size as Apple's desktop thing, the smaller one. I'm blanking on the names of it, but it's similar to that. But I think this is way more powerful. If you guys want to see a side by side comparison between this, whenever we get more full details about this from Jensen and Nvidia, and Apple's current state with iOS 18 updates, I believe that's what they're on, and everything from the recent stuff that they've showed for it. Let me know, because I think they're pretty comparable, but I think this is just way more powerful. Especially, you don't need plugs for it. He said it's wireless. It's a wireless cloud supercomputer that handles everything that they do at Nvidia. They run through that, allegedly. And if I'm understanding him correctly, and lastly from it, anybody, like, I can imagine a whole company in their office all running off of this one machine. I just can't imagine that. If that one machine is able to handle everything in their office, that is insane. I That's the crazy part about it. Like, let me hear. Let's actually hear him say it again. Did he actually?
connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Grace CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Black.
This is one of the things that I like about NVIDIA, how they break apart some of these products as well. So yeah, so you can plug this up, or you can just connect through Wi-Fi or Bluetooth, which is crazy. I couldn't imagine. How do you get this put on attached to Wi-Fi though? 4 terabytes SSD. What the hell? This is insane, actually. Like, this is part of the reason why I like looking at Nvidia's keynotes and stuff, because you get to see the breakdowns of the inside of everything. My question is, do you have to connect it to the computer first to put it on Wi-Fi, and then once when you do that, you can use any device on it, or exactly do you do the pairing for it? I wonder where all those other buttons and stuff probably are, because it doesn't seem like you need to do much to really connect it to go from this. But this is getting long. The last thing I want to say is they also do have AI assistants, and he went through all the other stuff of how you can use these AI assistants to help their engineers develop more. And they use this in their own offices, and they add everything up together. And I wish that this showed that, but maybe since it's so tailored to engineers, I thought it was an amazing thing. If I can find, I might do a whole separate video on that one thing alone for engineers. If you guys want to see that video, let me know. I will record it. I'm gonna put a note down for myself. But thank you guys for sticking around for another video of Dev Talks. Hope you guys all like, comment, and subscribe. Go down in the description and do me one favor, please. Look at the email in the description. If there's videos that you want reacted to or to get somebody's perspective, send me an email with the email down below, and with the YouTube links. It can be multiple links, it can be one. Any messages that you guys want to go off of and things, especially for people who want to get interviewed and things. That's something that's going to be coming up real soon. Let me know in that email down below. But thank you all for tuning in to another video. Appreciate y'all. See y'all next time. Peace out. And if you want to see more videos like this, click the video that pops up right about now. Thanks.